Hello friends, I'm Sumant and today we are supposed to discuss about storage classes in C programming language. So in this video I'll be discussing about the syntax and what are the properties of all the storage classes and what are the total storage classes available, and we'll be discussing in detail about each storage class. So where exactly do we use storage classes? Storage classes are being used when declaring a variable. So when you are creating a variable, you will be defining its data type and the variable name. But the storage class will also be there, but it is being taken care by the compiler depending on the context where we are declaring the variable. Okay, depending on the area and depending on the scope. Okay, fine. So if you are creating a variable called integer x or float x, you are requesting the compiler to allocate 4 bytes of memory to store integer type data. And if you are creating a variable with float x, we are requesting the compiler to allocate 4 bytes of memory to store decimal data. Okay, the same way it goes with character type and double type. So depending on the data type, compiler will understand what is the type of data the user is going to store or the program is going to store, and how many bytes it is supposed to be allocated. So but here nowhere we are discussing about its scope, nowhere we are discussing about whether it could be accessible to other members, or what would be its initial value, what is its storage locations and its lifetime. So these properties would be taken care by the storage class. So if we are talking about the location where it has to be stored, there are two possibilities. One could be the RAM, or other it could be register. And when it comes to scope, it has two possibilities of storing a variable. It could be local to a particular function or a block, or it could be external, which could be used by any other member or any other file. External storage, external data or variables could be accessed and could be used by any other members. Okay, so we could also name it as a global variables. So let's make it or global. Okay, when it comes to lifetime, if you are storing a variable inside stack, we would be deleting its memory as soon as the function termination has been encountered, or a block termination has been encountered. If it has been created inside a block, it would be deleted once the block is terminated, and it would and if it is created inside a function, it would be terminated. The memory would be clear as soon as the control encounters the function termination. I mean, as soon as the control comes out of the scope of the particular function. Okay. When it comes to heap, if you are storing a variable inside heap, the memory won't be deallocated. The memory won't be erased until the program termination happens, like until the control encounters the end of the program. Okay. When it comes to default value, there are two possible default values. One would be 0, or it would be a garbage value. There is also a null default value possibility, but it is applicable for pointers. We'll be discussing about these pointers, null pointers, in detail in other video or in other coming sessions. Okay. Basically there are 4 data storage classes in C. One is automatic storage class, and its keyword is auto, and register storage class, external storage class, and static storage class. So we will be discussing about each storage class in detail. Let's talk about automatic storage class first. Let us consider we have a simple C program, which is having only one function, that is main. So let's declare a variable over here. Let it be integer x, and let us see what is its value when you're printing it. Okay. It is printing some garbage value. So we have created this x variable inside a main function. So its scope is up to main function. You cannot use it outside the main function. Okay, the same way, if you create a variable with the same name inside a block is nothing but whatever enclosed within flower brackets is nothing but a block. It could be if condition, or if conditional block, or else conditional block, or simply a block. Okay, block %d /n comma x. Same way, main %d/n, right? So here this is function scope, and here it is only up to block scope. This scope is the scope of this particular variable is only confined to this particular block, and the scope to this variable is confined to the whole function. You can access this variable throughout the whole function. Okay, in order to differentiate it, let us initialize with some value 1. Okay, and let's paste this printf after the block to get a clarity on what variable being called, or what variable being used at the time of printing this particular statement. Okay, okay, now if we can see, this particular printf is printing the variable x, which was defined inside a block, and this particular printf is printing the variable x, which was defined inside the main function. As soon as the pointer encounters this end of the block braces, the scope of this x variable would be terminated. I mean, the scope of this x variable is only in between these blocks. The memory would be erased, and if it is a function, if you are calling it again and again, the memory will be created, deleted, and then again created, and again it is deleted. If we could say, it could be stored in stack. Okay, so this is about auto keyword. This is about auto class, auto storage classes. Even though if we are not specifically telling that it is an auto storage class type variable, the compiler itself will take care of this auto keyword. But whatever the variables, whatever the variables declared inside a function or inside a block are by default considered as auto variables. Okay. And we have seen these auto variables were initialized with the garbage value. So initial value here is garbage value. Okay, the same applies to the variable with the function scope, but that garbage value is being replaced with 1, so we are unable to see its initial value. Okay, if we use an auto keyword, or if we won't use any auto keyword, it won't make any difference when it comes to local variables. But if you use the same for global variables, uh, we have created the same variable name outside the scope of the scope outside the main function, whose scope is global. I mean all the other functions and the functions from other files could use this particular variable. But if we create this variable with auto keyword, let us see what happens. I'm building this program. Let me close this. Let us build this program. If you could see, here we are getting a warning, that is X has bad storage class. If you could follow my mouse cursor, you could see this warning in the third line of my code, which is having bad storage class. This compiler, I'm using MVC compiler. I think it is ignoring this auto keyword because it is the latest compiler being used. In previous version compilers, you could notice it would be given as an error. The compilation won't happen if we provide this kind of illegal keywords which is nowhere related to the scope. Okay, so auto keyword should only be used inside a function or inside a block, and it could not be used, or it is not suggested to be used outside a function, that is which is supposed to be in the global scope. Even though if you use it, it would be provided as a warning, but it don't consider it as a auto variable. Okay, it by default takes it as another storage class that I will explain you further. It is always suggested to initialize a variable with some default value when you are creating a auto type variable declaration. Okay. That is why you are getting another warning which is saying uninitialize local variable X. So here previously we have not initialized with any value, it is having some garbage value. That is why compiler will suggest you that to initialize with some default value in order to avoid any ambiguity or any pre-assumptions being done, taken by the developer, that it would be initialized with some default 0 value or something, but it's not the case. Okay, now let's go with register type storage classes. So let me tell you, this auto type storage classes are by default. If you create a variable, by default it is considered as auto type, but register type storage classes are not default. If you are explicitly mentioning it as a register, then only you are supposed to create, then only the register type storage classes are supposed to be created. Okay, in auto type storage classes, your memory would in auto type storage classes, memory would be allocated inside RAM, and when it comes to register type storage classes, memory would be created inside registers, right? So as auto is only supposed to be used for local variables, even registers have the restrictions to be used only inside local variables, because register type storage classes does not support global variables. Okay. It does not support global variables. It is having, because it is having some explanation. I will give you an explanation why we are not supposed to use this register type storage classes in for global variables or external variables. I'll explain you further. Let's stick on to the local variables right now. Okay, we have created a register type storage class variable. It does not make any difference in terms of initialization. You would be having the same garbage value, the same scope, but it would be stored not inside RAM, it would be stored inside register. So registers are small memory locations located inside our processor. So whatever the computations happen in our code, whatever the arithmetic and logical operations happens in our code, they were being done in the processor. So whenever the data, stored data has to be has to be taken out, and the value has to be computed, that process is being done in between RAM and the processor. Okay, whatever the variable stored inside RAM will be fetched at runtime during computation by processor. So the fetching and again storing back the computed value, and again fetching some values, some other operations for some other operations, and again storing the result into RAM, and passing on the data in between RAM and processor is a kind of time taking process. Okay, so in order to avoid such kind of time taking process, we would be using register type storage classes. So but we have to be very careful in terms of size constraints. So we have a very limited size inside a register, which would be 12 KB or some 16 KB. Okay, 12 KB or maybe 16 KB. When it comes to RAM, you will be having 2 GB 3 GB RAM, so you will be having ample of space to store your data. So generally we store register type variables which are loop counters, which are the variables which were being used very frequently in our program multiple times. But we use this only for local variables, because if you are storing a register type variable inside, if you are storing a memory 2 bytes or 3 bytes or 4 bytes of memory inside a register, and if you are running out of memory, and if your computation is so heavy and you don't have any space further more space to compute any other operation, so it won't make any sense, even though if the performance is good, the overall program is supposed to be failed. So it is always advisable to use register type variables only for local variables, because those local variables, as soon as its scope ends, it would be deleted. The memory will be refreshed, right? And whenever a new function is being called, the function whatever the variable which was being defined as a register type, it would be loaded into the register, and the computation, whenever a function execution happens, its data members would be loaded from the RAM, and whatever the data member which was declared as a register type would be allocated. That's the memory for that would be allocated inside register, and whenever the function execution is completed, the register type and other variables would be freed, memory would be deleted, and it would be preserved for future operations. Like if you're calling any other function, if the program control goes to the same function again, the memory would be again created for that particular register type, and such that the memory will be refreshed for every certain period of time. When it comes to global scope, the memory won't be cleared up. So it makes sense not to use uh, register type register type data in the global scope, because programs are dynamic in nature. We would never know when how much resources are needed for sake of computing some heavy operations, or if there is much workload on your system, and if your memory is not if register memory is not free and it is being occupied by some variables. So it don't make any sense for performing for performing operations when you're compromising on the speed. Okay, but it is not guaranteed. We cannot give any guarantee when it comes to register type storage classes. It is not guaranteed to be stored inside register. It depends on the hardware availability. If you request your compiler to store it inside register, first it will check in the register whether the space is available or not. If the space is not available, or if there is some other operations going on, heavy operations or something, some parallel computation is going on, if something is going on in your hardware, and there is no access of memory, there is no free memory available, then it would store inside RAM. um, so we cannot guarantee whether the register type storage classes works really or not. Let us run this code in order to verify whether what is the initial value. So it is same as auto keyword, but it have the only difference is storing inside a RAM or inside a register. Okay, let us try it out with the variable outside a function. Let's build it the same way we have seen auto keyword. Whenever we have used auto keyword outside a function which is in the global scope, we got this particular warning message that is nothing but X has bad storage class. In the same way, we got the same warning message for register type storage class. So it is not recommended to be used. Even though if you use it, the compiler will ignore, and it will by default won't consider this particular storage class. Let us talk about extern type storage class. So till now we have seen the storage classes which should only be used for local variables, with whose scope is only there available for local variables. Okay, let us see for extern type storage classes. Extern, you could see the keyword. By keyword itself you could understand that extern means external. External is something which could be used by some other external part which is visible to everybody, right? External and internal, the same way. The keyword is nothing but extern, which should be visible to everybody, or which is extern is something which is visible to everybody and which is accessible to everybody in the sense all the members, all the functions, and for other class members and all. Let us see if we create a variable called integer x. Okay, so we have created an integer x, and we have not initialized with any value, and we have not even used any keyword like extern. So but its scope is global. It is accessible to any function. If you create a function called test function, and let us declare this function. Printf test %t /m x. So we have not created any variable x inside text function, but we are able to compile this particular code, and we are able to run this code. Okay, sorry, we have not called this test function. The function has to be called. We declared, we defined it, but okay, right. So it is by default initialized with 0, and we don't need to explicitly create a variable by using an extern keyword, right? We are not supposed to use extern keyword when you are declaring it inside your main file. Like if you want it to be in a global scope, and whenever you are creating this particular variable, its memory is being allocated. If you want its memory to be allocated only once, the global scope in the sense its memory is allocated only once. The address of this particular memory is same, even though if you use it in other file or any other function, the address of this memory block would be same. Okay, let us run this code. Right, if you could see your test 0, nothing but here the value is being initialized with 0, but we have not used any external keyword over here. We could say it will be created inside heap as its scope is global. I have a function called extern test and other C file called new file.c, which is in the same directory. Okay, so I will be creating a variable called x, and I don't want the memory to be created again. I want the same x variable to use it again. So let us see how this extern keyword works, and let us call this particular function. Okay, so we called an extern x equal to 0. So in order to differentiate whether it has created a new memory or whether it has used the same variable, we'll be differentiating by initializing it with 2. I have initialized this external variable with 2. So you could see this extern x2 has been printed. By this we could confirm that the same variable has been used. If you need more clarity, you could also print address of x, let's say, and x, such that we would be able to confirm whether the same address is being shared in between the two files. Okay, just compile it. Okay, it is giving this particular warning because we have not declared it before calling this particular extern test function from new file.c. If we declare it prior, it won't give any this kind of warnings. Control F9. Let us see. You could see this memory address 1135.0.0.0 and extern x 1135.0.0.0. So by this we could clearly confirm that the same memory has been shared in between main.c and new file.c. Okay, I think you got better clarity over here. I'm not using extern keyword when I'm creating a memory, but I'm using extern keyword when I am trying to access a variable which is being already created. Even though if we won't use extern keyword, it will automatically consider x as an extern because it was already defined. Okay, so as I told you, extern scope is only confined to confined to the variables which are declared outside the function. But if you explicitly give a local variable extern, it will throw a compilation warning or a compilation error. It is cannot initialize extern variables with block scope. We got a compilation error, which is nothing but cannot initialize extern variables with change its value. This is a bad storage class declaration. So we should not use extern keyword when we are declaring a variable inside a function or inside a block. So we got a linking error over here because of using an extern keyword. Okay, otherwise I'll be using Z over here to see if it works. F9, same thing is happening, like it is giving error. The code will behave abnormally, so we cannot guarantee whether it will give an error or a warning message or a linking error. So it is not recommended to use an inappropriate storage classes. Okay, let us remove this thing. Let's talk about static storage class. As we spoke about the static storage, the external storage class, as its scope is the global, and auto and register types, like storage classes scope is inside a function or inside a block which is local. When it comes to static, it is having two scopes. It could be a local or it could be a global. It could be used along with an extern or it could be used along with auto. But it cannot be used with register. Let us experiment it with register. More than one storage class. So we cannot use two storage classes at once. So as we know, whatever the variables declared inside a block or a function are auto, so we would be assuming all the variables have auto keyword before it, as most of the storage classes cannot be used in a combination with other storage classes. So we should assume that whatever the variables inside a block or a function are nothing but auto keyword, nothing but auto storage class members, class variables, and which were declared outside a function are external variables. Let us as I told you, the static storage classes have two scopes, that is global and local. Let's experiment with local static storage class. If we create a static storage class int z and we are printing, let's create this particular int z inside a function to show you the difference between the static what exactly does static mean. Okay. Let me comment out this external test. Let's focus only on the local variables, static local variables. So I am printing this test z over here. I'm incrementing the z value later on. So remember, whenever we are creating a static variable, so it will be by default initialized with 0. If you could see, sorry, to be %d, so it's being initialized by default with 0. Let me call the same function again and let me execute this thing. 0 is incremented to 1. How is this possible? You might be having a question, how is this possible? So whenever a static keyword is used, memory allocation is done only once. It is same as I explained you in external keyword. So whenever you are creating a variable in the global scope, its memory is created only once, even though if you use an external keyword in other file, its memory won't be created again. Or even though if you re-declare it again, its memory won't be created again, right? Its memory is created only once. We have also seen by printing its address. Same way, if you whenever the first time when we are creating a static int z, its memory is created once and it is stored inside a heap. inside heap in a RAM. Okay, let me keep it in capitals. Right. Whenever memory is created in heap, its scope is till till the end of the program, until our return 0 has been executed. This particular Z's memory won't be destroyed. Let us discuss about static storage class inside a local variable when it is being used with a local variable. If we are using a static variable and initializing with some value 2, and you are trying to increment its value, let's build and run. So we have initialized with 2 and again whenever this particular line has been encountered by the program counter, the control, this would be ignored the next time, the second time. This is the first time it has been called here. This is the first call. It will initialize L with 2, and in the second call it will ignore this statement and it won't initialize. It will directly print this variable. So I mean to say the memory has been created only once and initialization is done only once. Okay, but if you as you can see the output, it is 2, 3, 4, 5 and 6 and 7. But if you don't use static keyword, this particular statement would be executed every time and it would be initialized with 2 as many times as we call it, as you can see over here. But this is what the functionality of static keyword in local scope. If we use a static keyword in global scope, let us consider we have this external variable called int x equal to 2. We used a static keyword over here, and we already have a file called newfile.c which is using this extern int x. So as per our variable, it should be initialized with 2. Let's see what happens. Let us remove this. Let us uncomment it. It is giving some errors because this static keyword will restrict the usage of integer x only inside this file, which is main.c. It won't allow, this keyword won't allow it to be used outside new file. If we remove the static keyword, we could see there would be no compilation error. But if we put the static keyword, it is restricting to be used only inside this file. It will give you a compilation error. But if we remove this external keyword, the memory would be created again for this file, which would be separate memory for the separate file. That is nothing but new file.c. Sorry, we have printed the address instead of the value itself. Let's remove and operator and we'll put %x. Let's run it now. We could see extern x value is 0, but we have declared it as 2 over there. Instead of 0 it should have printed 2, but as it is explicitly defined as a static storage class type variable, it won't allow that particular variable to be used outside its file. Let's see what happens if we remove the static, and when we try to print that particular function, when we try to call the particular function which was defined outside our file, it would be giving as 2. So you could figure out the difference when used static and when we are not using static in global variables. So the thing is, it is being used in order to restrict its scope. If you want its scope only to be inside the particular file, we would be using static keyword for global variables, and if we want a memory to be allocated, or if you want its memory should not be deleted after the function termination, you should use static for local variables. So that's how this particular static storage class is used. That's it, guys. Thank you for the session.